Chapter 3A, Section 3.2, we're going to look at the basic atomic structure and identify the locations of protons, neutrons, electrons, define an isotope, and demonstrate the ability to represent various isotopes symbolically. Some basics to remember: electrons are negative, and they're located outside of the nucleus. We represent electrons with an E negative because it has a negative charge. Protons are located inside the nucleus, and we represent them as P plus because protons have a positive charge. And then neutrons are neutral and located inside the nucleus, so we represent with an N, 0, 0 representing neutral. So the nucleus is the most massive part of the atom. It contains both the protons and the neutrons. Electrons on the outside are very, very, very light in weight as compared to protons and neutrons. If you could imagine the nucleus being a nickel placed in the center of an LSU football stadium, and the stadium is the electron cloud on the outside, and yet all of the mass is located in that nickel in the center. So it's very small as compared to the whole atom, but is the most massive part. The atomic number and the mass number can be found on the periodic table. The atomic number is the number of protons. So the atomic number of hydrogen is 1, of magnesium it's 12, of chromium it's 24, of carbon it's 6. The mass number, which cannot be located directly from the periodic table, is the number of protons plus neutrons, which implies that this should be a whole number. You'll notice on our periodic table we're not dealing in whole numbers, we're dealing in decimal places. So these that I'm circling are actually known as the average atomic masses of each of these elements on the periodic table. What is it an average of? It's an average of all of the isotopes of the element. So the mass number on the periodic table is an average of all the naturally occurring isotopes of that element. The average on the periodic table represents the most abundant isotope. So if this is the average atomic mass for lithium, then the most abundant isotope of lithium must have a mass of 7. Isotopes are atoms of the same element that have different masses due to a different number of neutrons. So if we look at this diagram, these are all atoms of lithium because they have the same atomic number, which means they have the same number of protons. And you can see down here in blue, those are 3 protons for each. However, they each have different masses. So if we look at the numbers at the top, this has a mass of 6. That means 3 protons plus 3 neutrons. This one has a mass of 7, which is 3 protons plus 4 neutrons. And this one has a mass of 8, which is 3 protons plus 5 neutrons. So you can see that our protons stayed the same the whole time, but the neutrons can change, which will change the mass number. So now we're going to learn how to represent isotopes symbolically. And on the periodic table, you'll find the symbol in the center, you'll find the atomic number at the top left corner, and you'll find the average atomic mass at the bottom. However, when we write symbols, we're going to put the element symbol. The atomic number will actually go to the bottom left of the symbol, and the mass number is going to go at the top left. In this case, I'm using the most abundant isotope based on this average atomic mass, which is 24. So let's do a few examples. If I had iodine 127, identify the number of protons, neutrons, electrons, the charge, the mass number, and the atomic number. We're missing a number right here. If we look at our periodic table and find iodine, we can identify that iodine's atomic number is 53. So that's the number that we're missing right here, 53. So the atomic number is 53. The atomic number tells us the number of protons, so we have 53 protons. If I want to know the neutrons, remember this number right here is the protons and the neutrons together. If this number is just the protons, I could subtract them, and that would give me the number of just my neutrons. So when I subtract these, I get 74. So we have 74 neutrons. Now, notice here there is nothing written, which means that this has a charge of 0. It's neutral. That tells us that the protons and the electrons must be equal to one another. So there's 53 electrons balancing out the 53 protons. and our mass number was given to us 127. Let's try another one. Here I have scandium. They give me a mass of 46, and this time I have a charge present. The charge is +3. That means that my electrons are going to be different than my number of protons. First, we need to know what are our protons. So we find scandium on the periodic table, and the atomic number is 21. So that's the number that we're missing right here. 21 is the atomic number, and it's my number of protons. We're given a mass number of 46. Then I'm going to subtract 46 and 21, and that's going to give me 25, which is my number of neutrons. Now to figure out my electrons, I'm going to take the atomic number, 21, and we're going to say 21 minus 3 equals 18 electrons. Notice we did the opposite of what the sign says. The reasoning is because we have 3 more protons positive than we do negative electrons. So we should have a +3 overall charge. So just do the opposite of the sign, 21 minus 3. One more example, we'll look on the periodic table for the atomic number of selenium. So selenium is over here, and the atomic number is 34. So if I know the atomic number is 34, I also know that I have 34 protons. Now, my mass number is 79. If I subtract my mass number and my atomic number, then I would get the number of neutrons, which is 45. Finally, I'll take 34 plus 2 equals 36 electrons. Because we have 2 more negatives than we do positives, we have an overall -2 charge. When asked to do the reverse, we are given this information. An atom has 23 protons plus 29 neutrons in the nucleus. What is the symbol? We need to know what is the element first, and we're going to use the number of protons to figure it out. Protons identify the element because they are the atomic number. So I need to find number 23. Number 23 is vanadium, V. So I'm going to write V for vanadium. I'm also going to write the atomic number, which equals the number of protons at the bottom left. Now what I need is my mass number. The mass number is the protons plus the neutrons. So I'll add 23 plus 29, and that's going to give me 52 as my mass number. Finally, I want to determine what's the charge. And notice that they don't tell us a number of electrons. However, we do know that it's an atom, which implies that it's neutral. So we can assume that there are 23 electrons balancing out the 23 protons, and so we do not need a number here because it's neutral. One more example. Here I have an ion, which does imply that we'll have a charge. It has 30 protons, so we'll look for the element with number 30, and that would be zinc. So we're going to write zinc, Zn. We'll put the atomic number at the bottom left, and then at the top here, remember, we're going to add protons plus neutrons, and that's going to give me a mass number of 65. Now I need to have a charge, and we're going to use the electrons to figure out the charge. The fact that I have 2 more protons than I do electrons makes this charge a +2. You could also check your work by taking 30 minus 2 should equal 28 electrons, and it does. So our final answer should look like this.